Okay, let's get started. Colorful cubes demo. Okay, so yeah, in this playlist stream video, I want to start making a new 3D puzzle game that I've been making some levels for a while. That's been in my head for a while. And yeah, I think we're just gonna make this in Zig and raylib to begin with, and then if the prototype turns out to be really good, we'll think about what to do next. But yeah, where should we start on this? I think something sensible to do would be to just copy in the raylib files and the build file from the last project. So yeah, let's start by making a main file. And let's see. Test here. What exactly do we want to copy in? So we'll do a lot of this again. So we should really call this is like, this is a, let's do like, this is a like puzzle game about the geometry of cubes. Making this from March to who knows when. We will figure out what this is later. Okay. Standard. We can get rid of almost all of this. We'll still be using raylib. And let's just say like standard dot debug dot print hello cubes. Like I've recently been doing some stuff in Odin, so it may take me 5 minutes to get back into the Zig manner of things. Okay. Let's see, we also want to copy over raylib stuff from basically everything in here. Copy this over here. And then we also want to copy the build file from this as well. So let's see. That was not the way to do it. Copy. Okay. And then let's just name this. What should we call this? Colorful cubes demo. Yeah, for memory, I shouldn't have to actually change anything else from here. So get rid of this one. Get rid of this one. Okay, let's just build this then. Where's my screen again? Okay. Okay, yeah, so from memory, there are some starter examples on like the raylib website of just doing like some easy camera class to start with. Oh, that's right. In Zig, we need to put semicolons and everything. So I feel like today I just want to. Did this not run? So yeah, today I just want to get just like a cube rendering on the screen, and then we'll take it from there. So if we go to like raylib examples, I do like camera. This is basically what this example is kind of what we want, what I want to start with. Okay, so where's the code for this? Raylib example. Okay. I don't think we should do anything else. Okay, so yeah, what are we doing here? So I think we can initialize this like last time. Yeah, let's just we have some globals, constants. Constants. So let's just say in const initial screen width. We'll make this okay, instead of using like the 1080 by 920, let's do the thing we did on the last project. Okay, which was to say we'll make like the screen width actually, I think it was like 1080, and then we wanted this to be like a 4:3 aspect ratio instead, just to make it somewhat smaller to begin with. So it's kind of 3 to 4, we want to divide this by 4 and then multiply by 3. Okay, and we can say the screen width is something we'll actually set in here. Yeah, how do we do this in this again? I think all of this we want to copy over. And then yeah, we just want to have this. And yeah, we need to set window title. So we'll call this, in Odin it would be that, but this is now C. So we call this colorful cubes demo. And then, our window should close. We want to render our cube. So that's right. We have differencing. Begin drawing. We want to defer rr.end drawing. And then we kind of do stuff in the middle. Okay. Okay, so how do we get a grid and a cube drawing? What's this? Define the camera to look into our 3D world. Okay, camera is just some struct. Raylib has its own vector3 format, which we need to do our own version of, which is totally fine. So why don't we say, how do we do this in Zig again? Can I simply say, is it at vector, let's see, how do we define vector? Yeah, at vector 3, comma f32. And then some stuff here we can ignore. And what's the important part? Begin mode 3D. Okay. Important. Stuff we will ignore. And then this draw cube function. Okay, we're going to draw this cube by drawing triangles. So we need to like draw a 3D triangle instead. But otherwise, this seems straightforward. Okay. So we want to say, let's just clear the background. Oh, okay. We're going to have to copy in some color stuff, but that's fine. And then we want to do this rl.begin mode 3D. And then a camera, which we'll need to define. And then end mode. Yeah, end mode 3D. But without a camera. And then to do the actual 3D drawing code. Let's deal with the colors now. So what did we do in the last project? In the last project we just defined a bunch of colors. We may as well just copy those over. So we just said, yeah, say like we just have some simple version of black now, which is just every value is 0 except the last one. And then that's fine. And then we needed to write a function that converted this color to raylib's color. We also needed a type. So I guess the color here is just for F32s. I am going to be forgetting some semicolons today. And then what was our, this one, like this DOM color conversion function. And then okay, we now want to draw some triangles. So we can define one of those as a constant as well. So let's just say well, okay, if we're drawing triangles, we may as well actually start, we should like, okay, we really should think about some kind of shape library similar to the one we did in the last project. It was really simple, but it worked. All of these are 2D ones, but I think this would still be fine. There is something to be said though in this project for basically setting up like vertex buffers and color buffers, like all of this stuff, and then just getting raylib to call it in some dumb way, but with the intention that we're going to be using Vulkan or DirectX 3D down the line. Before we've got anything on the screen yet, let's just focus towards that, and then we'll immediately do this. Okay, but we'll really need to think about this carefully. Okay, so we'll say like, yeah, think about how to think about data structures so that drawing triangles just writes info to some buffer which at a later stage will be sent off to the GPU. Okay. But for the moment, let's just define some triangle like this to begin with. But now it's a 3D triangle, so we need these like 3D vectors instead. So we can just say test point 1 is a vec3, which is going to equal, say like 0, 0, 0. And let's say point 2 is also a vec3, which is now, we'll keep like the z axis 0. Oh, actually, like, it's not immediately clear to me in raylib 3D which version is up or down. We'll figure this stuff out. 1, 0, 0. And then likewise, let's make this 1, 1. And then we can just say test triangle. Yeah, we'll just make this equal to a fixed array of 3 vectors, which is test p1, test p2, test p3. Then we want to actually convert these convert our vector3 into raylibs. So presumably I can just change all of these around and it's fine. So now we just want to say z is vec2. Let's call this vec3 to raylib. Then let's draw one of these actual triangles. So let's check out the cheat sheet again. And there should be something on here called like triangle 3D. Or maybe just draw a triangle. Draw triangle. Okay, draw triangle 3D. Pass in 3 vectors and some color. Okay, that's all it is. So raylib.draw. So let's do like 0.1 is equal, not Odin syntax anymore. So yeah, P1 is just vec3 to raylib of our test triangle 0. Then we want to do draw triangle 3D, P1, P2, P3, then the raylib color black. Okay, and then we finally need to choose the camera. So let's do that. Where's our raylib example? So how does this stuff work? It's just this, which is pretty simple. But let's look up the code for this. So now we want to do colorful hues demo. And then we'll just check raylib files for camera. So what have we got? 315 in raylib.h. Source. So yeah, this is literally it. It's just position, target, which way's up, field of view, okay, and then some projection, camera perspective or camera orthographic. Okay. Let's just add this in. Oh, but for some reason that's not commented. Okay, so how are we going to do this? We're going to say raylib const camera is going to equal, we'll just have a type of raylib.camera, and we'll make it undefined at this point. But we're going to define it right now. So then we say, well, in that case, we can actually just say camera equals raylib.camera, and then say the position is equal to something. So let's do vec3 to raylib. Let's just make this similar, 10, 10, 10. And then the target, we want to be equal to, oh, hang on. Since this is, since this is a C struct, it may not actually like us specifying stuff this way. Okay, we'll go back to the org version. So we'll say this is a camera that's undefined. And then we'll just say camera.position is convert this. When we're starting off, I'm going to be doing, I'm going to want to do a lot of manual tweaks. So it might be better just to say camera position here is equal to vec3 10, 10, 10. all of this is going to be dynamic very quickly, but we'll keep it here to begin with. And then camera.target. Let's just make this look at the origin. So in a similar way, let's just make some constants. So we'll say the origin is just going to be a vec3 that's 0, 0, 0. Vec3 to raylib origin. Not the name of the phenomenal film by Ava DuVernay that came out a couple months ago. The mathematical origin. And then camera up will be, I guess this is just going in the Y direction. Let's create some unit constants for this as well. So we could do like unit, like unit X is just vec3 this. And then we'll do like unit Y and unit Z as well. And then we want this to be 0 and 1, 0 and 1. Okay. So vec3 unit Y, unity, and then camera POV. I guess we can leave this as that. And then camera projection raylib dot camera perspective. Okay. Position target up. Yeah, we've done everything there. So then, oh, this is camera 3D though. And then I guess I think that's it. So let's, unless I missed something, let's try and compile this. So build run. Okay. Use of undeclared identifier, initial screen with, yeah. We should just make the name sensible. 86. Oh no, it's still, why is it not recognizing this? Initial screen width and initial screen height. Are these not here? Oh, initial screen height. Okay. 79 cannot assign to constant. Of course. 95. Oh, expected rated color. .113. Expected U8 found F32. Oh, did I specify the, so silly, colors are just 4 bytes. Undefined symbol, draw triangle 3D. Oh, we may have to go into the build file and turn this on then. Okay. which, good thing that we created this file in the previous project, and so we know how it works, most of it. Okay. I mean, we're not yet calling model procedures, but I guess these are, okay, draw a triangle 3D is under our models, so let's just turn everything on. Except audio for the moment. We'll leave audio on. Okay. And then I guess this means we add those in as well. Okay. Okay, there is a screen, but it's empty. Okay, so let's like add in a grid first to make sure we're actually seeing something. So in like the raylib example, there was like a call to a grid. Oh, here it is. Draw grid 10 and 1. Okay. So let's just say rl.raylib draw grid. Like we're gonna write our own, we will almost certainly be writing our own grid procedures, but for the moment we'll use this. Okay, great. This is good. This is progress. So let's just save everything we've done so far. Oh yeah, I guess we need to like init something. So yeah, git init here. We almost want to add everything, but let's just think about this. When I mean think about it, I mean let's copy the git ignore file from previous projects. Yeah, we don't want any of that stuff. So git ignore. Okay, so now I can do git status. So much stuff. So much stuff. Let me just say like init project. And now we can basically add everything. And let's just make sure this is okay. We should also make sure that like raylib hasn't released another version in the meantime. I don't think it has, but it could. No, the latest is still version 5. There's so much stuff in here. Like I am kind of tempted to use the Mac Engine glfw library. But maybe this is not the time to start experimenting with that. But then kind of why not? We'll do it later. Like trying to like use raylib with Mac is a fool's errand. But once we've got the basic prototype working, and we've been developing it with all of the buffer stuff in mind, then we should be able to just swap to Mac, to the Mac engine stuff. Okay. Well, we'll keep this for the moment. But yeah, I don't see any unwanted files here. This all kind of looks important. So we can say like, yeah, added like, yeah, drew a grid to the screen. Okay. Let's just make something on GitHub in which to push this stuff to. Oh, what's this, like unread notifications? Oh, was this added in? Oh, cool. This is done now. There should be a button here that says like, you can delete this branch. Yeah. Okay. This branch can be safely deleted. Okay. Good. Because yeah, I figured like, yeah, I may as, given we built this thing on screen, it may as well be added to like this list of other SIG projects made from scratch. Okay. But let's make a new thing. So create new repository. So let's call this colorful cubes demo. Yeah, a demo for a 3D puzzle. Yeah, a demo for a 3D puzzle game exploring the geometry of the humble cube. And yeah, we will, like everything, we'll make this public, but I don't want anyone submitting any pull requests to this, so we're going to have to make it clear in the README that that's the case as well. Yeah, we'll do this later. I think that's fine. Okay. Okay, so now I just want to do push it from the command line. Yeah, git remote add GitHub storage, that, and then we just want to do, we're already on main. Git push you main GitHub GitHub storage main, right? Yeah. Okay. And then, as we found out last time, this isn't always updated, but it is here. And then, weird, why isn't it showing my, why isn't it there? Okay, I guess this wouldn't yet be showing stuff. Why is this not like showing my icon though? Weird. But does this normally happen? I feel like this doesn't. Is this like another bug with GitHub? We'll see. Anyway, okay, yeah. So where are we at? So we're at this, and so now we want to say. Well, now we just want to get a cube rendering to the screen. So, and we want to do this with triangles. So, so in this game, we're going to want cubes with, so the cubes in this game are going to have many colors. I think what we'll want to do is create a function that just creates a bunch of vertex and color data with which to draw, which will, yeah, just create a bunch of triangles which will correspond to, which the render function is just going to like draw the triangles of, and then that will draw a cube. So let's do this. So we could say function make colored cube, and how would this work? We have to start thinking about the geometry. You could say in the procedure below. So like the thing here is that like we need to pass in 4 colors, and those 4 colors will correspond, sorry, 6 colors. Those 6 colors will correspond to the 6 sides of the cube. But of course the order is really going to matter. I kind of want to just make a net for what the cube will look like. So we could say something like color 1 goes here, and then like color 2, color 3, color 4, color 5, color 6. I kind of don't like this though. I feel like if I want to think about colors, I want like this to represent a net of the cube where C1 is at the top. And then, what's the best, well like what is a way to like label these that's intuitive? Okay, I think it should be as follows. I think it should be like the top, and then like north, east, south, west, and then the bottom. Yeah, C1. Okay. That's enough for me for the moment. This will get rewritten. So the other thing is, do we want to specify a position of this thing? I don't think so. Oh, maybe we kind of do. So I think instead I want to say make, what I really mean is like render. Like we're gonna implement animations, but the animation will just be like rotation, so nothing complicated. I'm thinking too much ahead. Let's just render this in some obvious way to begin with, and then we'll adapt it as necessary. But we will actually make a struct called like a colored cube. Or maybe just a cube. We'll adjust the name as necessary. And I think for this is the one where we want to just have all of these sides that are different colors. So we can just have color 1 is color 2, etc. Oh, what's happening? Okay, and then let's make one of these. So let's just make some cube where every single side is like green. We can do. We'll make it debug. So we'll do debug. We'll make this magenta. I feel like all of these should be like double zeros. And then, well, this is magenta. And then like we may as well give this a decent color to begin with, I think. Why don't we just choose some of the colors from our last app? Right, this was why don't we just make it this color? So let's see. Why don't we just pick the light blue and the grey blue? The light green and the light blue. We'll get rid of the dark green. So then we just want to say we'll call it cube 1. Would just be just make lots of things like actually let's make this one where the very top and bottom are light green and everything else is that won't help with perspective. Let's make it so the top, bottom, and the north side are light green. In other words, we want to say light green, light blue, light blue, light blue, then light green. Okay, and then for this render this color cube, we just want to take in something that is one of these cubes, and then okay, instead of a void like this, this probably still should be a void. We now want to just draw the triangles necessary. So compute 12 triangles, which when drawn will draw the cube. We'll do this. I realized that currently, okay, maybe there is a triangle being drawn here, but I can't really see it. We should fix this part first. So draw a triangle 3D, and instead of making this black, let's make this a debug. Oh, we're already getting an error. Oh, I think it's like const cube equals struct. And this is going to have a second. And we haven't yet used cube. Come on. Okay. The pink triangle is getting drawn. Things are fine. Okay, so now we'll do cube. Okay. So we're gonna have to like figure out how to do positions and other stuff in this as well. But why don't we just make it a convention that like the width of all of these squares is just 1, and then that will make it easier. Yeah, like that's just, I think that's a sensible choice. So I guess we need to first define the vertices of this cube. Compute the 8 nodes of the cube. So let's just say we really should be passing in a position. Hey, like I think like the position should represent I kind of want to say should represent like the center of the cube. Let's see, like what do we... This is a good thing to think about. Like this is something what we want to get right, like immediately, since everything else we do will depend on this. Yeah, I feel like when it comes to like just like the rotations and all of that, the position of the cube really should be like the kind of center of it. So then okay, this should be fine. It just means that if we're keeping track of the position of this cube in terms of some like integer grid coordinates, we just bump everything by 5. Okay, this is fine. So we'll have a position which is a vec3. And then we want to compute the 8 nodes of this. So what's a decent naming convention? Maybe point like 0, 0, 0. And then like 0, 0, 1, etc. Can I do like, what's the macro? If I do like and 3 that, no, it's control Y. Why am I bothering to do this? We know how to do this with macros. Const p0, 0, 0 is equal to vec3, 0, 0, 0. I think that's 4. Okay. 1, 1, 0, 1, 1. Okay. That was unnecessary. 1, 1, 1, 1. And then we just want to like repeat those here. Okay, and now we've got all of those. We want to construct the appropriate triangles with them and the colors for them. So we really should come up with our own structure for this. So let's say triangle. This will be just a struct that has 3 points that are colors. And then that are vec3s. And then a color. And then we just want to compute what these things are. And this should be okay. We then just want to actually have like a draw triangle function that calls the sensible, that currently calls the raylib one, but later on will store this information in the appropriate buffer. So this is a void. And so where's the, what's it? It's just called draw triangle 3D. So I guess we just want to say in a similar way here. Triangle dot p1. That's p2 and that's p3. And then triangle dot color. Okay. We should really have, maybe do this in a for loop. We can just say for triangles draw triangle. Oh, with the, this isn't gonna work. I mean, I guess it would actually. It's just now we have to like save the colors when we're saving these triangles, which actually I think is fine. Like for the moment, I feel like this is what should be happening. We may need to adjust this later on. Feeding their color. Which when drawn will draw the cube. Okay, so now we want to say if we want to say C1 triangle, which is C1 triangle is now triangle, but now with, yeah, with the appropriate points. So we're starting off, we're starting for the top face. So the top face should be, so it also really depends on actually how we're drawing these things. Let's just keep all of the diagonals going from the origin outwards. So the triangles for the top face we'd want would be P1, 0, 0, P1, let's say we just go up the x-axis, the y-axis, P111, and then like the color, which we want cube.c1. But actually, like the C1 face has two triangles, so like C1 triangle A and C1 triangle B. We now want P0, 0, but now we want P1, 1, 0, P1, 1, 1. And the same thing. Okay. And then, yeah, we just have to figure these out for the others, but that's okay. C2 triangle A. So now we're doing the north side. So the north side will be P1, 1, which way, like, okay, it's in my head which way to do it. So P1, 0, 0, 1. This is, there's going to be errors, but we'll find them and we'll fix them. Maybe that's actually a better way of doing this. It's fine. We're doing it from scratch. I really should annotate what these are. P, X, Y, Z. Okay. So now with this in mind, let's start again. So yeah, 0, 0, 1, 0, 1, 1, and then 1, 1, 1, 0, 0, 1, P1, 0, 1, P1, 1, 1. Now we want to do 0, 1, 0, 0, 1, 1, P1, 1, 1, P0, 1, 0, P1, 1, 0, and then P1, 1, 1. Now we do the east side. So now the east side is P, or which way do we, okay, we'll do things that way. 1, 0, 0. 1, 0, 1, and then 1, yeah, P1, 1. And this one is now P1, 1, 0, P1, 1, 0, P1, 1, 1. Okay, the south side, not the show, even though the show is amazing. 0, 0, 0, P 0, 0, 1, P1, 0, 1, Zero, 0, 0, 0, 1, 0, P, oh no, that can't be right. P1, 0, 0, P1, 0, 1. Okay, so I think the way to check all of these is that, like, in some sense, if we if we do like a bitwise OR on these digits, these two should add up. So that's fine. That's fine. No, that's actually not fine. Wait, why am I saying this should be like a bitwise OR on these? I'm being silly. And we need to add colors to all of these as well. So cube.c1, cube.c1. I'm sensing macros. Or the easier version of macros. Okay, so now we're onto the west side. So it's that, and now P001, and then P011, and then still this, and now I want this to be 1, 0, and then 1. Const C5, and now we need to do the south phase, which should just be the same as the north phase, but now the final digits are 0 instead. And these are 6. Okay. Define all of those, and then we're drawing them. So let's check if this works. Oh, and then it's nearly midnight. This will have to be it for the moment. Undefined entry point procedure main. What? Oh, it's because we're not building stuff in Odin. We're doing stuff in Zig. Okay. Okay, fix that. Redeclaration of local constant. Yep. That's what happens when you copy past. Use of undeclared identifier triangles. So we should need exactly 12 of these. And these should be equal to C1TA, everything here. And now we're going to say, delete, what? Why is that happening? Emacs, I just want to like delete all of that. Why aren't you letting me do that? So I can like replace it all with a space just fine. Okay. This seems like really, this doesn't seem like the right approach. This at least seems a bit better. Okay. 184. Okay, fine. Not using position. Yeah. That's because we need to like, we need to add in the position to all of these. So actually what we want to do is to say, it seems like if we just add in like plus pos x plus pos y, etc., things will get kind of messy in here. Oh yeah, wait, what am I talking about? It's just we simply add them in up here. So now it's just let's see, plus pos dot. Oh, it's just plus pos. No, that's it. Okay, nothing there, which is fine because we haven't yet called it. So now we want to call rendered colored cube on cube 1. So render colored cube on, we also need a position. So why don't we say like pos 1 is equal to like 1, 1, 1. We'll adjust this. Okay, let's make it to 0, 3. Then is it cube 1 plus 1? Okay. Main cube does not support array initialization syntax. What? Okay. This is all just completely redundant. I don't know why I called it this stuff. The cube should just clearly at this bit stage be 6 colors. Okay. And then that should now be fine. And then for all of this stuff here, we just want to say and then we want to like decrease them by 1. Oh, how do you do that in Emacs? Yeah. How do I decrease a numeral in Emacs? Like, what's the shortcut? How do I decrement a number in Emacs? Like, you can do this in Vim, so surely there's some... Oh no. Oh no, okay, we're not doing that. No. It's okay. We'll just do 0, do it the new way. Main triangle now does not support array initialization syntax. But this is ridiculous. Why not? Odin allows you to do this. Why not Z? This is tedious. Whatever. No, not yet. Let me define a new macro, come on. P1 is this. P2 is this. P3 is this. And then color is this. What? Does it want like a dot in front of each of these? It did. Okay. Great. And now we've got some geometry drawing. Only half the triangles are drawing, which is surprising. I think this is because of like raylib stupid. We're only going to draw a triangle when like the vertices are in a like certain orientation issue. So yeah, so we're just going to draw triangles by drawing the triangles twice with both orientations of vertices. Done. Okay, there we go. Yeah, this looks like an okay cube. Okay, I kind of want all of these sides to have different colors now. I've changed my mind. So let's go back to this, and 1, 2, 3, 4, 5, 6 colors. One of them is kind of black. Let's just pilfer all of these colors. Aside from the black one, and let's just use all of these in the cube. Cube 1. So what is this? Light green, dark green, light blue, grey blue, brown, and this yellow too. Oh, come on. Okay, good, we can see 2 of them. And then let's change the camera so that we see the other side as well. That's working. But also, we need to really create our own custom camera. So is it, right, this camera position I said was something we want to adjust, and so, okay, that we want, yeah, we want to adjust this. So I think actually in raylib, Y is the one that goes upwards, and so I think if we do a -10 and -10 here, we should see the other, we should see like the other faces of the cube. We'll see. Yeah, and we do. Great. We're still not seeing the bottom, but that's fine. We can easily do that as well. Yeah, fantastic. Okay, yeah, I feel like this is enough progress for today. We're drawing a colorful cube, so I'm happy with that. And yeah, okay, let's think about what we want to do next time. I think next time it really will be just setting up this like data structures, and then actually drawing our own custom create our own grid drawing function, or really procedure, and then actually, that can kind of wait. This one can wait. What we really want to do is we want to start animating. We'll start moving the cube. Start moving, animating the cube. This will be fun. We'll get to do some linear algebra. We'll get to just like rotate the cube. I want to press keys. I want to press arrow keys and have this cube moving. Let's save all of this. So let's see, we added in lots of code today. So main, I can say rendered, started drawing a cube on the screen, or just like created or wrote render cube, wrote render cube that takes in a cube and a position. Okay. Now that's on GitHub. At least it should be. Yeah, and then okay, it does say now. That's good. Dude, like, what's happening with GitHub? Like, it seems to be. Why is this not recognizing me as the author of this? I am confused. I'm very confused. Like, if I do this, and I do commits. Oh, okay, again it's like no logo, but then if I do like this one, like, why is this, like, it just bothers me that this logo appears sometimes and then not other times. And I don't understand why this is appearing in this one and not in others. Yeah, like this is kind of annoying. Okay, it's me being picky. Nothing more. Nothing more. Then, like, why isn't it appearing here? Like, it's... No, this is really annoying me. Okay, I'm just gonna, like, end the stream here since this is unnecessary, and I'll just figure out what on earth's happening with GitHub. But yeah, thanks everyone who came by. See you next time.